When you build Dataverse plugins like this in C#, your work doesn't stop after writing the code. You still need to tell Dataverse when and how to run that code. And that typically means switching to a separate tool, like plugin registration tool or XRM Toolbox to configure everything. The problem is, all of that configuration lives outside your code. So when you're writing your plugin, you're making assumptions about filtering attributes, targets, and so on that are not guaranteed to be correct. There is no visibility in your project about how your plugin is wired into the platform. And over time, it becomes harder to keep everything synchronized. That disconnect is what inspired XRM Tools, bringing everything back into the code so your intent becomes explicit, consistent, and version controlled. In traditional approach, when you come back to a project or when someone new joins, you're forced to jump between tools trying to reconstruct behavior and understand how everything fits together. It slows you down, introduces mistakes, and makes the whole development experience feel fragmented, especially compared to modern workflows where everything is clearly defined in code. With XRM Tools, you define your plugin registrations directly on your plugin class. It makes them visible, version controlled, and they live right next to your logic. There's no guesswork, no jumping between external tools. And with that in place, registering your plugin is as easy as right-clicking it in Visual Studio and clicking Register Plugins. If you enable plugin code generation, like this, it means you can even register a single plugin as well. Writing these registration attributes are very easy too. Let's say contact. For filtering attributes, it's the same experience. But code generation will also give you some interesting stuff. Let's remove this line and save our plugin and take a look at our code behind. So here you have a bunch of methods that are used for dependency injection, some more utility methods, and then you have a target entity here, which looks like an early bound, with just the attributes that you have asked for. Then you have a method here that gives you the dependency injection. Let me show you how you can use it to make your plugins even easier to write. Say, for example, I need to set the owning theme of my target. Here's the owning theme. If I need to have more attributes here, I can simply choose them. Let's say, for example, created on, save. And now if I go back here, I have created on as well. Let's store that in a variable. But if I do that, it will give me a warning, basically saying that, okay, I started using dependency injection without any scope. So we need to do something like this. AI already knows what to write, and that fixes the problem. Whenever you want to use anything that depends on dependency injection, you have to have a scope defined in here. But you can go further with the dependency injection. Say, for example, you need the tracing service. You can say you have a dependency on eye tracing service, and you just need to say require eye tracing service. Now we can easily use that eye tracing service here. If you look back at the generated code, you'll notice that now we have a new line in here, which is giving us the eye tracing service. You can even go further by adding more and more dependencies, even your own custom services, and that makes your code easier to write, easier to test, and easier to reason. Let me show you an example that I already have here. For example, this contact greeting. As you can see here, it is registered on 2 different steps: create and update. Here I have several dependencies. Most of them are custom classes. And here I have just a scope and I'm setting a description. But it's even a little bit more complicated because we have a plugin base in here. And if I look at the code behind now, you'll notice that it has much less methods because the code generation detects if you have moved these methods up to your base class and it will not generate them again. So if we go back to our class and here we go to our base, you'll notice that we have here all these dependencies that I anticipated that they will be used in other plugins. And I have here a more defensive execute. And then I have here an internal execute. And I have just copy pasted all those methods from the generated code into my base class. Now, if we go back to that plugin, you can see how terse and minimal the code here is. There is basically nothing to test. And you can have single responsibility services that are much easier to write and easier to test. But what if you already have a lot of plugins in your projects that you have already written in the traditional way and you want to convert them to the new modern way that I showed you here? Let's imagine we didn't have any of this in place. You had just a traditional plugin, no dependency, of course, and you have registered it using the plugin registration tool. What you can do is basically come here and add a plugin attribute. And I have previously registered this plugin assembly. So if I hover my mouse over this plugin attribute, you will see a screwdriver will appear. If I click there, it says expand plugin attribute and add step and images. So it will basically go back to your environment and collect that information and it can write the missing code for you. So now we have a modern plugin that we can easily register. And as for the dependencies, of course, you will have to write them by hand. But this is something that you can opt into. I don't necessarily need to use dependency injection or any other features from the generated code. But as I improve my code gradually, I can start using them. But what about custom APIs? Let me show you. I have here a custom API. Again, it has a plugin attribute at the top. It has a name, and you can optionally add a display name, description, and so on. There's a lot that you can define here. And then the interesting part is this. This custom API is different. You don't need to use plugin registration tool to define every single parameter, input or output. What you can do now is to define a class, and I usually call it request, and then add an attribute, custom API request. After you do that, whatever property that's in your class becomes input parameters of your custom API. The same goes for your response. You define a class with properties and just add a custom API response attribute at the top. You can add other metadata to these properties here, like for example, if you want to make them optional, if some of them are required, some of them not. It also looks at the nullable character. So if it sees that you have used a nullable character here, it will make that property optional as well. But it goes even further. So for example, you can have early bound entities as your parameters, or you could have anonymous entities basically, or you could have IEnumerable of those early bounds, or you could have, for example, an enum here. Look here, for example, we have an enum, and then the code generation will take care of converting it into an option set when it's reading or writing that parameter. Registering it is just like any other plugin. And if you have custom APIs that you have written before, the same way you can basically convert it to the new model. Another feature I would like to show you is native fetch XML queries. So imagine I want to write a fetch XML query here. I will just right click and I will add a new fetch XML file. Let's give it a name. Let's add a few columns. After you save your query, it runs automatically here and you can verify it, but it also generates the code behind file. And it's basically the code that you need to run your query. So if I go back, for example, to my plugin here, I can easily call that query like this. But here it needs an I organization service. Let's add one. And now we can easily pass it to our query. Just like that. What about early bound entities? That one is even easier to write. So let's say, for example, you want to have a couple of entities as early bound in your code. The only thing you need to do is to add an assembly level attribute. So here I have, for example, an entity of contact, and I didn't specify the name of the columns that I need. So it actually will contain all the columns of contact. Or here, it's a bit more advanced. I am asking to use a dedicated base entity class that I have created before. And that class is defined a little bit below here. You see, it's a class that is inheriting from an entity. So imagine you might want to have different kinds of accounts. You could have a base account class and generate all different flavors of account and inherit from it. You can do really sophisticated stuff with that. Here I actually have a couple of utility methods in my base class that can be interesting to have, and I want to share it across all my entities, so I'm inheriting from it. Say, for example, I was interested in only a few columns. I could simply say attribute names. And then here I have code completion that helps me not make mistakes. Let's say, for example, I am interested in the address, in the first name, and in the last name. So when I save this, the code behind will contain all of the things that I have asked for. So if I search, for example, for account, or it was contact, if I'm not mistaken, I have it here, further below. So these are the attributes that I asked for. And I always get a lot of interesting methods here as well, but I let you explore them yourself. There are many other features in XRM Tools. I will leave the link to the wiki below, and there's a lot of other videos that I have recorded. You can refer to them, and make sure to subscribe so you are informed about new features as I add them in the future. Thanks for watching, and if you have questions, please leave them below. I will do my best to answer them. See you in the next one.